A drinking bird is a science toy which demonstrates properties of evaporation and mimics the motions of a bird drinking from a glass of water. Technically speaking, it is a heat engine, which means it uses heat to produce motion. To use a drinking bird, simply arrange a glass so the bird's head can dip into it. Next, dunk the bird's head in water and then release it so it can swing freely. The drinking bird will keep moving until there is no more water in the glass or until you stop it. The drinking bird consists of a glass tube which connects two hollow glass bulbs. The top bulb and beak of the bird are covered with felt so that water can be absorbed. A liquid with a low boiling point fills a portion of the bird's bottom and part of the tube. The rest of the bird is not filled with air, but with a gas form of the liquid, which is exerting pressure evenly on the inside of the bird. The bird is then hinged between two plastic legs. The feather on the back of the bird is just decoration and is not important. There are a few different kinds of drinking birds, but all are made of the same base components. Let's start by looking at the bird while it's swinging back and forth. The experimenter has just dipped the bird's head in water and the felt is wet. The experimenter then released the bird so it's swinging back and forth. Next, the head of the bird cools down because the water on it is evaporating. This is also called evaporative cooling. Evaporative cooling happens when some water molecules gain extra energy from their neighboring molecules. In this case, the neighboring molecules are the surface of the drinking bird. Now that some of the water molecules have more energy, they can break free from the water and become a gas. This leaves the lower energy molecules behind. Because the remaining molecules have less energy, they are less hot than before. That's why it's called evaporative cooling. You could also say that the water takes heat energy from the drinking bird, heating up itself and then evaporating, leaving the drinking bird's surface colder than it was before. It's like if you have a pack of runners and you select out the fastest ones to be on another team. The average speed of the first team will decrease. Now, the bird's head has cooled down. That means that its head is colder than its bottom. Because the head is colder, the air inside the head shrinks. This causes the pressure exerted by the gas form of the liquid in the bird's head to decrease. Now that the pressure in the head of the bird is less than the pressure in the bottom of the bird, the higher pressure in the bottom can push the liquid up to the bird's head. Now, the bird's head is heavier than its bottom, causing the bird to tip back into the water. The bird's head again gets wet. While the bird's head is in the water, the bird is tilted so the tube connecting the bulbs is raised above the water level in the bottom bulb. This allows an air bubble from the bottom of the bird to travel up to the top, equalizing the pressure in the bird and letting the liquid flow back to the bottom bulb. Finally, the weight of the water in the bottom of the bird causes the bird to start rocking back and forth, restarting the whole process. 1. The bird's head gets wet. 2. Water evaporates off its head. 3. Its head cools due to evaporative cooling. 4. There is now lower air pressure in the top bulb than the bottom bulb. 5. Liquid is pushed up due to the difference in pressure. 6. Once enough liquid gets into the top bulb, the bird tips back into the glass of water, causing its head to again get wet. 7. The pressure in the bird is equalized and the liquid flows back to the bottom, causing the bird to start rocking back and forth again. 8. The process restarts.